Hey, welcome back, guys. In this video, we're going to focus on identifying additive and multiplicative relationships. So before we get started, let's review graphing. So this table, you may have seen it in 5th grade. You also see it in 6th grade. Input-output table, that's one way we call it. But it's also actually ordered pairs from a graph. So I want to review graphing. Okay, so this is ordered pair 2, 4, and then this is ordered pair 3, 6, and this is ordered pair 4, 8. Now this graph lists all your values, so that's okay. That's not a challenge to graph unless you accidentally flip the X and the Y, and that's if the graph isn't labeled. That's typically when I see that happen. So this is my first ordered pair, and then the next is 3, 6, and then 4, 8. Now, that's all I have to graph. So in order to keep the video short, I'm just going to keep going. All right, so additive and multiplicative relationships. So the way you know it is definitely for the rule or the equation or the process. It's kind of multiple ways to identify it. If you're always adding to the X and the same number is being added, it's an additive relationship. My suggestion is pause the video, copy this all down. Now keep in mind, just because I said additive, that means you can add a negative. That's the same as subtracting a positive. So just keep that in mind. I don't want you to get stuck on the word additive, meaning you have to see an adding symbol. Here is a multiplicative relationship. It can be either y equals ax or y equals kx. K meaning constant of proportionality. Don't worry about that yet. Just remember that you're multiplying every time a value by the x to get the y, and it works all the way through. Okay, so let's keep going. So in this case, there's multiple representations. So when you have an equation, it's also a word problem, it's also a table, and also can be a graph, represented in a graph. So I'm going to start with the table because that's 10 to be where kids really do well with, because you've been doing tables since 5th grade. How does 1 become 13? Well, you could add 12. So I'm going to start with add 12. It would have to work all the way through for this to be the process. So I'm going to check it. Does 3 plus 12 give you 15? It does. 5 plus 12 give you 17? Yep. Now, you got to go all the way through, especially when you take a test, because I guarantee the third or the fourth one is not going to match, and you're not going to pay attention. You're going to pick the wrong answer. So every time you add 12 to x, you get y. We write the equation starting with y. I'm not saying you won't see an answer choice like this, at least for 6th grade. However, it's typically this way. All right, so let's keep going. We're going to graph. This is ordered pairs. So my first ordered pair is 1, 13. The next one is 3, 15. I already know, looking at my graph, I don't have enough lines. So what I'm going to do is just pick a couple of points. I'm going to pick this ordered pair. Okay. And then I need one more ordered pair. So let's first start there. And I chose that because I can make my intervals to work out for me. So for the x, I'm going to do 1, 2, 3, 4. For the y values, I'm going to do it in increments of 5s. And then I'm going to stop there. And I apologize because it's really a small graph, and I'm trying to work out my pen for it not to be so thick as it writes, but you know, it is what it is. Okay, so the ordered pair I want to graph is 3, 15. Now I can make my intervals anything I want. Now the question is, I need another ordered pair. So what I would do is I would use the rule, because I want something to give me, honestly, 20. So I'm going to work backwards. If my y value is 20, I subtract 12. That means this would be 8. Now, if you're going, what did you just do? Well, 8 plus 12 does give you 20. The reason I wanted this Oops. Because I strategically placed my y values in increments of 5. So that means 8, 12. Let's move up here, bear with me. Is I'm going to go to 8. So it's 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go to 20. And I know this is going to be the 20 in the next spot. So 5, 10, 15, 20. Okay, I tell you to do the hops like that. And I know a lot of times kids are like, oh, that's just cheesy. I don't want to have to do that. But I can tell you the mistakes get made because they don't hop over. They don't count spaces. They count lines. And I can tell you now that STAR knows you're going to do that, and that'll be an answer choice. So the verbal description is coming up with the word problem. So I could say every bookshelf, there's 12 books added. So bookshelf 1 has 13 books. Bookshelf 3 has 15 books. Oh, I'm supposed to write words. Sorry. I'm all over the place. Okay. So each bookshelf has 12 books. All right. Let's go on to the next one. Okay. This is probably easier to look at. A dolphin travels through water at a rate of 40 miles per hour. So per means one or each. So at 0 hours, 0 has been traveled. Now at 40, that means I'm going to times it by 40. Y would be 40 because this X, that's your hours and that's your independent value. The miles traveled depends on the hours driven. Or not driven, we're talking about a dolphin, sorry. Okay, I should start over, but I've done this video too many times and I'm tired. All right, so let's keep going. 2 times 40 gives you 80. 3 times 40 gives you 20. 4 times 40 gives you 160. So we're talking about a dolphin traveling. Okay. So if you notice, there's a 0, 0. So that means this is definitely an ordered pair. Now, I have to change my intervals. That's for sure. Now, keep in mind, if this is X and this is Y, in order to get Y every single time, you multiply by 40. Your equation is Y equals 40X. Now, 40 is your coefficient. Oh, coefficient. I'm misspelling it. Oh, well, sorry. All right, now we're going to, there's nothing labeled on the graph. So what I want to do with that is I definitely want to list out the hours. Putting 1, 2, 3, 4, that's not going to be a big deal. I'm going to put 1 here, 2 here, 3 here, 4 here. And only because of what I'm graphing. It's just a preference. You don't have to, you could have put 1, 2, 3, 4 at the first one. You decide how you want your graph. I'm looking at my Y values. There's no way I can do 1 through 160. However, I can do it in increments of 20. I'm not sure if that'll be enough, but we could try. 20, 40, 60, 80, 100. I'm going to just keep going. Okay, so now my first order pair is 0, 0, which I have. The next one is 1, 40, 2, 80, 3, 120, and then 4, 160. So I'm going to connect and make my line. Now, if you notice, it's a straight line and it goes through 0, 0. Meaning that's a proportional relationship or a multiplicative relationship. We typically say multiplicative relationship in 6th grade, and then we, switch over to proportional relationship in 7th and 8th, but neither here nor there. Okay, so now let's do a little bit of practice. If you're still here, I suggest copy the table down, figure out the rule yourself, and then unpause it. Okay. I personally don't like horizontal tables. I prefer to have it like this. I think from my experience of teaching, kids have better luck going this way. Okay, I'm only doing the first. I should do all of them. Okay, I'm going to start without the negatives. It's just a preference. I try to avoid negatives. I'll deal with them when I have to. How does 3 become 0? Take away 3. Now, the question is, does it work all the time? Well, that does equal 0. If I take 4 minus 3, that gives me 1. 5 minus 3 gives me 2. Now I'm going to check the negatives. So if I'm at 2 and I go 1, 2, 3. So this would be 1, 0, negative 1. So it does work. So my rule is, or equation is y equals, every single time I have x, take away 3, and that'll give me my y value. So this is an additive relationship. You could also graph so you could visually see it. All right, so let's look at this one. How does 4 become 12 plus 8? Now the question is, does it work all the way through? 6 plus 8 is not 18. However, let's try another way. 4 times 3, does that give you 12? It does. So we're going to keep on trying, make sure it all works. And if you notice, it keeps on working. So that means this is a multiplicative relationship. Every time you multiply 3 by x, you get y. So y equals 3x. Now, refresh your memory. X is your independent value, and y is your dependent value because your y depends on your x. All right. Here's another video. Here's another example. We can try to doing it this way. It doesn't look too bad because there's 0, 0. So that typically means it's a multiplicative relationship. I don't want to say forever, but I'm going to say for this is a multiplicative. We're going to double check. 2 times 3 gives you 6. Yep. 5 times 3 gives you 15. 9 times 3 gives you 27. The only reason I didn't rewrite this one because of the 0, 0. So our rule, our equation is y equals, every time I multiply x by 3, gives me the y. All right, I hope you're still here. Let's look at this graph. Now, I don't know why kids struggle with this. I think it's easy. However, from my experience, kids prefer to write down all the ordered pairs. Then they write the rule. So I know this is my x value, which is my independent value, and y are my dependent values. So this is 0, and then this is 1, 2, 3, 4, 5, 6. Now, the next one is 1 and 7, 2, 8, and then 3, 9. How does 0 become 6 plus 6? And I didn't even start multiplying because it didn't go through 0, 0. So plus 6, it does work, and it's looking like it's working every time. This is an additive relationship because every time you add 6 to x, you end up with y. All right, here is the last one. It goes through 0, 0, and it's a straight line. So that's a multiplicative relationship. I'm just going to grab 3 ordered pairs, 0, 0, 1, 4, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. How does 1 become 4? Times 4. Does that work again? It does. Now, y equals 4x. Why? Because every time you multiply 4 by x, you get the y value. All right. So if you're still here, I'm going to show you another way. No, I won't. Well, we're here. If you stuck it out this long, I got to give you kudos for that. I went up 4, meaning my change in y was 4. That was my vertical change. And then my change in x, which we use a delta symbol that looks like a triangle, but it's called a delta, and it means change. Okay. So you won't see that a lot in 6th grade, but it is good to know. So my change in x was 1, and then let's double check if I did it right. This should be 4. Yep, it's 4, and it's 1. This is a way to check me. And if you notice, Let's go back to the table. How does 0 become 4? Plus 4. How did 4 become 8? Because we added 4. How did 0 become 1? Because we added 1. How did 1 become 2? Because we added 1. Now, if you notice, look at the relationship from the table to the graph. It's okay if you don't get it yet. The important thing is finding the rule from a table or a graph. Whatever way works for you. It's not a big deal. All right. Well, thanks for watching. I hope this helped. And don't forget to hit like and subscribe.